Hi everybody, welcome to week 5 now, week 4, week 5 I think, of the refresher. We are almost halfway or just on halfway. Hope everybody had a good Christmas, good New Year break. A lot to get through this session. We're going to look at probability and fractions. Again, fractions are probably the one thing that I find trips most people up when they get to grade 7 and 8, because you start looking at graphs of algebra where they bring in complex fractions and people go, I'm working from home today, so my spare bedroom is the backdrop. That's why there's a bed there. All right, let's get started. I'll just move this to this screen. So I'll be going through examples and then leaving them up on the board so that you guys can work through with me. Let's start simple with fractions. Minusing fractions. Again, I won't spend too long on this because it is quite simple, but a lot of students get this wrong. Okay, so we have two different scenarios. Normally we have a situation where the numbers on the bottom are different or the same. Okay, so we're going to start with subtraction. So we have 7 over 12 minus 1 over 12. Nice and easy. We simply take the 7 minus 1. The 12 stays the same, and it becomes 6 over 12. Nice and easy. If we have addition, we can look at it like let's make it simple. 1 over 3, which would give us 2 over 3. If the bottom number is the same, we do not change it. We simply add the top numbers together, 2/3. The thing that trips most people up and they lose marks is not simplifying. So 6 over 12 could be simplified further than where it's at now. So it could be simplified to 1 over 6. So I'm going to put 4 questions on the board. And I will get you, I'll give everyone like 2 minutes to go through those and also simplify them, and then I'll go through them. Yeah, I'm not going to spend too much time on this as it is quite simple, but it's a good basic skill to wrap your head around. It does ramp up after this week as well. I'll start looking at Pythagoras theorem and sort of trigonometry and stuff like that. So just hoping to get these basic skills down. So if I have 1 over 6 and 2 over 6, I want the answer, but then I also want it simplified as much as possible. Okay. 10 over 20. And 1 more over here. So I need 1 minute to complete those and I'll go through them. So not only doing the sum, but actually simplifying it as well. I'll show my daughter. seconds. Okay. So if we have 1/6 and 2/6, we end up with 3/6. Or, as Izzy's just pointed out in the chat, 1/2. 1/2. So this one we would end up with 40/40 or 1. Down here, we would end up with 5/20, which gives us 1/4, because we divide those by 5. This would give us 2/5. And in order to simplify that anymore, we would need to have in order to simplify that, we would need to make this decimal. Okay. Let's round up the difficulty a bit. Okay, so what if they have different denominators? Denominators being the bottom. We have to make them the same. So if we have 2/6, any ideas what we need to do? So we need to find the highest denominator, being 12. So we do 6 times 2. But if we times the denominator, we have to times the numerator, which gives us 4/12, which would give us 5/12. Can we simplify that any further? All right, I've got another one for you guys to do. We'll do a couple together, one more together. So we have you guys 30 seconds to think about that one. So times by 2, which gives us 5/10, which we can simplify further to 1/2. Thank you, Harrison. All right. Give you a more difficult one now. Give everyone 1 minute to do this. Maybe 2 minutes, not really nice. Got a minute to finish this one. So Izzy and Harrison both said 7.5, which will give us so yeah, 7/10. Well done. What about a bit more complicated this time? Last one on this fraction, then we move on. Harrison says 13/75, and he's probably right. Or is he? So anyone want to adjust their answer yet? So that would be, okay, that's good. You guys understand that now. I don't think there was any. What about if it's a minus? A different denominator when it's a minus. So what would I do here? Can we just do the same thing again? Yeah, we just do the same thing. Give us 6/12 or half. Very good, Harrison. All right. Thank you guys. I'm good with that. All right, let's do probability. So the simplest way to look at probability is to look at the probability of one event occurring. I've got two sides of this. What's the probability that it lands on the yellow side? It's a yellow and a white. Or heads or tails. If I have a coin, what's the probability that it lands heads or tails? %, 1 out of 2, any of the above. Now I'm going to use my screen because otherwise I'd be here drawing for hours. Nobody wants to see that. Yeah, Izzy, technically yes, but when we're talking about probability, it's 50-50. Okay, so we have a spinner here with 5 chunks to it, equal in size. What's the probability that lands on the number 5? 20%, yep. Okay, what is the probability that this number, or that you pull an odd number out of those four numbers? As a percentage, 50%, very good. Okay. What is the probability it lands on tails? 1 out of 2. So one event out of 2 possible events. So 6-sided dice, probability that we roll a percentage. Sorry, that we roll an odd number, not a percentage. 50%. What's the probability of an odd number in this one? One out of 2. See how fractions and probability are closely linked together. So pick a card at random. What is the probability that the number you pick is greater than 3? Six out of 7. So what is the probability that this one is greater than 3? Four out of 5. So what's the percentage it would land on heads? 50%. Okay, what's the probability that it lands on a 7 and if you spin it once? 1 out of 6. %, rolling evens, yep. Right, a couple more of these and then we'll quickly move on. What is the probability that this number you pick is even? Right, last one. What's the probability that you spin this spinner and you get less than a 5? %? All right, let's skip on to the next thing. You guys understand that. It's great. Okay, let's do some worded questions now. Okay. So if Troy owns 15 t-shirts, 5 of which are gray, if Troy randomly selects a t-shirt to wear, what is the probability that it will be gray? One-third, perfect, you guys are smashing this. Okay, so a bowl contains 10 beads, of which 5 are white. What is the probability that a randomly selected bead will be white? Half. Perfect. So pick a card at random. What's the probability that you'll select a 4? as a percentage. Ooh, have to make it more difficult soon. So what is the probability that you would spin and land on 9 as a fraction? Last question. Probability to land on tails? Hey, you guys are learning something. Okay. So when we get into grade 8 and 9, we start talking about mutually exclusive, opposite and overlapping events. So mutually exclusive basically says you can't roll an even number and an odd number at the same time. So what's the probability that the number rolled on our 6-sided dice is less even or less than a 6? So easy, it won't be 100%. I'm going to give everyone 1 minute to think about this one, and then I'll probably jump on the board. I will go through this on the board. So Izzy, you are correct. It is 100%. I just wanted to explain to everyone how to get to that. So we're talking about favorable outcomes. So for even, we have 1, 2, 5, and 6. So 2, 4, 6 for even. Less than 6. We have 1. So we have 6 favorable outcomes over 6 possible outcomes. So as Izzy described, and yes, I was being mean, 100% is the probability that we get even or less than 6. So I'm going to do a sweet drawing on the board. You guys can go through it. So we have a spinner. Seven. So what is the probability if I spin my spin? I would get 6 or odd. %75%. So we look at favorable outcomes. We have 6. The odd numbers are 7 and 5. So that gives us 3 out of 4, or a 75% chance. Talking about, this is where we start talking about mutually exclusive events, events that cannot occur at the same time. What else? Let's do another one of these. Move on. So 1, 3. What is the probability that I pick a card that is not a 4? $75%. Perfect. Right, let's do one more, please. So if I have 5, 6, 7, 8, what's the probability that I pick 8? So Aris and Izzy both said 50%, very good. Perfect, because we have 2 favorable events, 8 or 6 out of 4 total events, which gives us a percentage of half. Okay. Let's look at picking independent and dependent events. So I'll tell you a story. Emmett and Brennan get on a roller coaster together and pick seats. Brennan picks a seat after Emmett does. Are the events dependent? Meaning the outcome of the first event affects the second. So if two things are independent, if the outcome of the first event does not affect the second. So if I have, actually I'm going to use the whiteboard, or the screen again, because it's good to be able to see a question. Okay, let's do this. In a certain board game, 2 players may not occupy the same space. Lorenzo moves to a space, and then it is Brennan's move. Are the 2 events dependent or independent? So they're dependent. Very good. Okay. Dirk picks a card at random. Without putting the first card back, he picks a second card at random. Are these 2 events dependent or independent. Remembering that dependent means the first decision affects the second, independent meaning they are completely unrelated and one decision does not affect the other. Dependent? Yes, because by taking out one of those cards, you're effectively changing the outcome of the second. Okay, Abdul buys a house in a new neighborhood. A few months later, Diego buys a different house in the same neighborhood. Are these two events independent or dependent? Izzy says independent. I think she might be right. So does Abdul buying a house in the area affect Diego buying? So the reason that there's a bit of a confusing, tricky, annoying question. But Diego only bought the house in the area because Abdul did. That's an annoying, I don't like that. Okay. A third grade teacher is assigning parts for the class play. Alex's role will be selected first and Franco will be assigned a role next. Are these independent of each other or dependent of each other? Harrison and Izzy both say dependent. No. All right, last one. So Irma spins the spinner twice. Are the two events dependent or independent? Harrison very quickly with independent. Yeah, because the first spin doesn't affect the outcome of the second. All right. And because I'm not going to stand there and draw, I'm going to use these. So if we pick a marble and spin the spinner, how many outcomes are there in total that are possible? So compound events are two things that happen at the same time. We count them together. So how many marbles and how many options on the spinner are there? So 25 is the answer I got from these guys. Perfect. So how many outcomes are possible here? So when we're talking about compounding events, you got to look at both of them. So Izzy says 16. Perfect. About this one here. Yeah, 12. Perfect. Last one. So flip a coin and pick a marble. How many outcomes are possible? 6. All right, you guys can back down pat. Don't need to do any more of that. So with a compounding event, you just take the total number of possibilities of each and times them together. Okay, now we're going to look at experimental probability. So I'm going to write out. Well, I'm going to speak it and then write it out. Actually, I'm going to show it to you on the screen, get you to write it down, and then I will go to the answer. That's probably the easiest. Okay. So we were looking at the experimental probability. So write down the numbers on there. Right, we've got that down, everybody playing along at home. All right. So 12 contestants. Helps when you get worded questions to just reduce the number of words. 12 contestants, 6 qualified for the bonus round. So what is the probability that the next person will qualify for the bonus round? So Izzy says 50%. Very good. So we take total number divided by what we're trying to figure out. 1 over 2. All right, I will do another couple of these. I think that might be it actually. Probability. Everything else in probability in the later years builds off these basic concepts. Okay, so Kyle is playing darts. He hit 5 bullseyes. In 20 shots. What's the probability that his next throw of the dart is going to be a bullseye? %, 1/4. So last one. So grocery store recently sold 10 tins of soup. 5 of those were mushroom. What's the experimental probability that the next soup is a tin of mushrooms? %. Yeah, 50% if you want. All right, you guys got that easy. That's pretty much all for today. Nice, easy, short one. Come back. The reason I put them together is because you can see what happens when you don't understand fractions. You start trying to do probability. To summarize fractions, it doesn't matter if it's addition, subtraction, multiplication, or it's the same principle. So 1/4 plus is still just times this by 2 times this one by 2. If there's a minus sign there, it's still exactly the same. Division, multiplication, it's all the same. Probability is quite simple until you get, once you get into grade 10 and 11, it can be quite tricky, especially if you're doing maths methods. But aside from that, it's not too bad. All right, I'm going to stop the recording. Okay. Thanks everyone for coming. I'll see you guys next week.